Hey everybody, welcome to Eureka Math / Engage New York Math. Mr. Quick here. Today we're going to look at Module 4, Lesson 5, Exponents. Exponents make multiplication easier, make writing long multiplication numbers easier, especially when you're multiplying the same number multiple times. And we're going to dive right into it. If I have 10 plus 10 plus 10 plus 10 plus 10. What is a faster, more efficient way of writing that? Now we see that we're using the same number every time, 10, right? We see that we're using addition every time. So this is essentially a repeated addition, right? So we have 5 times 10. That gives us a different way of writing 10 plus 10 plus 10 plus 10 plus 10. Now, if we change that to 10 times 10 times 10 times 10 times 10, we still have 1, 2, 3, 4, 5. We still have 5 tens, but in this case we are multiplying. And so we do have a more efficient way to represent repeated multiplication. This is repeated addition, which is multiplication. This is repeated multiplication. We're multiplying over and over and over again. And in this case, you would write it as an exponent. 10, which is the number that we're looking at, the base number, to the power of 5. That's not 105, that is 10 to the power of 5, because we have 1, 2, 3, 4, 5 tens that we are multiplying. Big difference here is this. Here, 5 times 10, we are adding 5 groups of 10. Here, 10 to the power of 5, we are multiplying 5 copies of 10. So this is repeated addition. This is repeated multiplication. And one of the big keys that we want to see here is that 3x is not the same, is not equal to x to the power of 3. Because if you have 3x, you're really looking at 3 plus, I'm sorry, that's not right. You're really looking at x plus x plus x, multiplication. If you're looking at x to the power of 3, you're really looking at x times x times x. So they're not the same thing. It's not the same as using a variable in a multiplication problem. It is, or a repeated addition problem. It is multiplying over and over again is what we're looking at. So let's go through a couple of examples. First of all, I think we need to look at some language here. So let's go back and let's look at 10 to the power of 5. First of all, when you write exponents, you want to make sure that your number is big enough that you can differentiate it, meaning it looks different from the actual exponent. So if we had 10 to the power of 5, you want to write it looking like this. You don't want to write 10 to the power of 5, because then when I'm looking at it, or when maybe even when you go back and look at it, you might get confused and think, is that supposed to be 10 to the power of 5? Is that supposed to be 105? It's kind of hard to tell, right? So let's use a little bit of vocabulary here. The number that you're multiplying again and again and again is called the base. So the base of this exponent is 10. The number of times you're multiplying it is this. That's, you can call that the exponent or the power. So I could read this number, I could say that is 10 to the power of 5. If I asked you what the exponent was, you could say 5, right? So I know that that is 10 times 10 times 10 times 10 times 10. I'm multiplying 10 by itself 5 times. So the number that you're actually multiplying is the base. How many times you're multiplying it, 1, 2, 3, 4, 5, that is the power or the exponent. Let's look at some examples here. We have an expression written here, and we want to write that in exponential form, meaning we want to write it as an exponent. So my base number is 5. That's the number I'm seeing every time. So I'm going to write that as 5. And to the power of what? Well, we have 1, 2, 3, 4, 5. So this one is 5 to the power of 5. Here we have a base number. The number we see is 2. And we have 1, 2, 3, 4 of those. So we end up with 2 to the power of 4. Going back, we have 8 to the power of 3. Now they're asking us to flip it. So this is the exponential form. They want us to write it in expanded form. They want us to write it out. So we know the base number is 8, so I'm going to be writing 8s. And how many am I going to write? I'm going to write 3. 8 times 8 times 8. 10 to the power of 6. Well, base number is 10, so I'm going to be writing 10s. 10 times, how many 10s am I going to write? I'm going to write 6. So we have 1 times 10 is 2, times 10 is 3, times 10 is 4, times 10 is 5, times 10 is 6. Oh, now we have a variable. Doesn't change anything. We have g cubed. When it's to the power of 3, it's cubed. You can still say to the power of 3, g to the power of 3. But if someone says squared, we know that's to the power of 2. If someone says cubed, it's to the power of 3. So we have g cubed, or g to the power of 3. So what is my base number? I don't know, but I know the exponent that represents it is g. And how many times am I going to write it? 3 times. G times g times g. So that's going back and forth between the two. Now let's actually solve some exponential equations. Okay, we're going to pick up with 5 to the power of 5. I know that if I was going to write that out in expanded form, that's 5 times 5. How many times? Well, there's going to be 5 of them, right? So we have 1, 2, 3, 4, 5. And I always break it down like this. I've got 5 times 5 gives me 25. I'm going to bring down this times 5. 5 times 25 is going to give me 125. I'm going to bring down the next times 5. So 125 times 5 is going to give me 625. Bring down my next 5. I have 625 times 5. That would give us 3,125. Now, I'm not writing out each of the problems. You can obviously solve it off to the side, or if the question allows you to use a calculator, you can do that. But I just want to show that mainly, so I wrote these two together, I brought down this 5. Once I had that answer, I brought down the next 5. Once I had that answer, I brought down the last 5. And I used arrows, and I went down a little bit each time just to show you that I'm keeping track of which 5s I've already multiplied and which ones I still need to multiply. All right, we have 8 cubed. So I know that's going to be 8. It's my base number. And I'm going to have 3 of them. 8 times 8 times 8. So what I'm going to do first is 8 times 8. And you know the drill, but 8 times 8 fell on the floor. When it got up, it was 64. I'm going to bring down this other 8. Or multiply 8 times 64. I don't know that off the top of my head, so I'm going to do it off to the side here. I know 8 times 4 is 32. I know 6 times 8 is 48. Plus 3 is 51. So my answer then becomes 512. I'm going to show you a little trick when it comes to 10 to the power of anything. So I know this is going to be 10. That's my base number. And I'm going to have 6 of them. So 1, 2, 3, 4, 5, 6. Here's a little trick when you multiply. Since you're multiplying by 10 and you're just moving the decimal, I'm going to take the power, and that's going to tell me how many zeros are in my number. So I'm going to have my 1, I'm going to bring down, and then whatever the power is, the exponent, that's how many zeros I have. So I have 1, 2, 3, 4, 5, 6. So I end up with 1 million. If you didn't know that, and you were going to multiply each of these, you'd get the same answer. There's no right or wrong way to do it. I'm just showing you a shortcut. That only works for tens. 10 to the power of 3 would be the 1, and then there'd be 3 zeros, right? Because you'd have 10 times 10 times 10. 10 times 10 is 100. Bring this one down. Times 10 is 1,000. There's your answer. That only works when you have 10 to the power of something. Okay. Oh, fractions. Yay. 1/2 times 1/2 times 1/2. Well, if I was going to write that as an exponent, that would be 1/2 cubed. Now, because we do fractions and it almost looks like 13 halves, when you do a fraction with an exponent, you put the fraction in parentheses. So here we go. We have 1/2 times 1/2 times 1/2. We know that when you multiply fractions, you're just multiplying straight across, right? So 1 times 1 is 1, times 1 is 1, so we still have 1. 2 times 2 is 4. 4 times 2 is 8. So 1/2 cubed equals 1/8. Okay, 2/3 to the power of 2, or 2/3 squared. We're going to have 2/3 times 2/3. We multiply across. We have 2 times 2 gives us 4. We have 3 times 3 gives us 9. So 2/3 squared equals 4/9, because that's already in simplest form. Okay, ooh, exciting here. We've got decimals. Hey, this is going to be 0.75, because that's our base number here. We have 1, 2, 3, so that means we have 0.75 or 75 hundredths cubed, and we're just going to do the math. So you have 0.75 times 0.75. Because I'm going to run out of video time here, I'm just going to bust out the old handy calculator, but you get the same answer either way. That gives us 0.5625, and I still need to bring down my other 0.75, so I multiply that again. So that times 0.75 gives us a really long answer, 0.421875. That's a long one, but that's what the answer is. It is what it is. Okay, here's another example. 21/10 times 21/10. Well, if we're going to write that, we would have, obviously, 21/10 as a fraction, so we'll put it in parentheses, squared, because there's 2 of them. So if we multiply across, 21 times 21 is going to be 441. 10 times 10 is going to give us 100. 100 goes into 441 4 times. You have 41 left over because 100 times 4 is 400. 41 hundredths, which is in fact in simplest form. So there you go. All right, now that we've talked about exponents, I hope that helps. You have that video to go back to. Thanks for watching. We'll talk about some more examples in class. And we'll go through some more when we're face to face. So anyway, thanks for watching, and we'll see you soon.